Welcome to Lesson 3, Difference of Two Squares. During your previous lesson, you have already learned how to factor polynomials using the common monomial factoring technique. For this lesson, we will learn how to factor polynomials using the difference of two squares. So first of all, we need to understand what is a square of a number. So the square of a number is the result of multiplying an integer by itself. The same principle applies for polynomials as well. So let's take a look at an example. So the question here is 16 a square number? So 16 is a product of 4 multiplied to itself, which is 4. So 4 times 4, you get 16. So therefore, 16 is a square number. Now, here is a list of other square numbers. So we have 0, because 0 times 0 is equal to 0. We also have 1, because 1 multiplied to itself is 1. Next, we have 4, because 2 multiplied to 2 is equal to 4. 9 is also a square number because 3 times 3 is 9. 16, as shown in our previous example, is a square number. And 25, because 5 times 5 is 25. There are other square numbers, so it is up to you to figure out what the succeeding squared numbers there are. For polynomials, the same principle applies. Study the example here carefully. So, analyze the exponents of the polynomial carefully. So, the first example, we have x squared. X squared is just a product of x multiplied to itself. So, x times x, you get x squared. Therefore, x squared is a squared polynomial. Next, we have x to the power of 4. So, x to the power of 4 is a product of x squared times x squared. Therefore, it is also a square. X to the power of 9 is a product of x cubed multiplied to itself, which is x cubed. Therefore, x to the power of 9 is also a square. So you need to remember that in order to use the difference of two squares technique for factoring polynomials. Now that you know what is the square of a number, we can proceed with factoring polynomials using the difference of two squares technique. So when an expression can be viewed as the difference, meaning it involves the operation subtraction of two squares, let's say for example a squared minus b squared, then we can factor it as quantity a plus b times quantity a minus b. Meaning this is the pattern that we will be using. So if your expression has both square terms or both terms are square numbers and it involves the operation subtraction, you can use this pattern. Okay, let's look at an example so that you will understand better what I am talking about. Example number 3, factor the expression 25x squared minus 16. So first things first, you have to analyze, are both the terms squares? So let's look at both terms. 25x squared. Can we get the square root of 25x squared? Yes, the square root of 25 is 5 because 5 times 5 is 25. And obviously, the square root of x squared is x because x times x is x squared. Therefore, the square root of 25x squared is 5x. So, 25x squared is a squared number. Okay. Next, let's take a look at 16. Is 16 a squared number? So 16 was already in our previous example. So we know that 4 times 4 is equal to 16. And the square root of 16 is 4. So therefore, both our terms are squares. And it involves the operation subtraction. So therefore, we can use this pattern. So factoring the whole expression, we will get a factor of 5x plus 4x times quantity 5x minus 4x. We got the square root of 25x, which is 5x, and the square root of 16, which is 4. So we have applied our pattern successfully. Let's have another example in our next slide. Last example. Factor the expression a squared b to the power of 4 minus 81. Again, we have to analyze first, are both terms squared numbers? Okay, so let's take a look at the first term, a squared b to the power of 4. So can we get a square root for a squared b to the power of 4? The answer is yes. The square root of a squared is obviously a times a. So its square root is a. B to the power of 4, you can have a square root of b squared because b squared times b squared is b to the power of 4. Therefore, the square root of this entire expression or term is ab squared. Okay, so our first term, we have already confirmed that it is a squared number. Now, let's take a look at the second term. So, the second term is 81. Can we get a square root for 81? Answer is yes. 9 times 9 equals 81. So, the square root of 81 is 9. So, looking at our expression, the second term is also a squared number. And it involves the operation subtraction. Okay, so factoring the whole expression and using the pattern that we had earlier, we can get an answer of ab squared plus 9 times ab squared minus 9. So I hope that you understand our lesson today and how to use the difference of two squares factoring technique. So as a recap, for this lesson, you have learned the difference of two squares. So when an expression can be viewed as the difference of two squares, meaning both the terms are squared numbers and it involves the operation subtraction, then we can factor it as quantity a plus b times quantity a minus b. Or we can simply use this pattern. So that is all for our lesson for today. For lesson 4, we will be continuing with the different factoring techniques. See you next time.